Alright, so this is our last video of the chapter, and we're just going to do a little bit more modeling with quadratic equations, okay? So we're going to solve. Alright, so on dry asphalt, the distance d in feet needed for a car to stop is given by the equation d equals 0.05 s squared plus 1.1 s, where s is the car's speed in miles per hour, and we want to know what speed limit should be posted on a road where drivers round the corner and have 80 feet to come to a stop. With any word problem, you always want to label what information they give you. Well, 80 feet, that's our d, the distance they have to come to a stop. We're trying to solve for s, so let's plug in what we know. We're going to use that formula up there. So 80 equals 0.05 s squared plus 1.1 s. Again, as with any quadratic equation or any equation in general, I can always start off by trying to graph y1, y2, because as we've seen in this chapter, graphing is going to work the majority of the time, so hopefully it's going to save us some time. So let's try that. Again, in this equation though, instead of s, we're going to put x, so x is going to represent our speed. So now, using our calculator, come over here and do that. Go to y equals, clear out any other stuff that you have, so 80 and y1 and 0.05 x squared plus 1.1x. Okay, as soon as you verify that you got everything typed in correctly, hit graph. Anytime you start a new picture, hit zoom 6. Now, I'm looking for a point of intersection, so I don't see that yet, so I'm going to try to zoom option 0. Now, it looks like a point of intersection will be somewhere here, so I'm going to zoom out. And there's my point of intersection. Also looks like I have a point of intersection over here on the left, but remember we're talking about x's, so if I go to the left, that's negative x's, which represents speed. Let's think about it. Can I have negative speed when I drive a car? No. No way possible to have negative speed, so I don't need to worry about this point of intersection over here on the left. I only need to worry about positive speed, because that's the only thing that makes sense in terms of this problem. So second count, option 5, first curve just hit enter, second curve just hit enter, and then guess. I want to move my cursor into position before I hit enter. Once it's there, hit enter. And so my speed, s, is about 30.5 miles per hour. So as you round this curve, you can do so safely at about 31 miles per hour, give or take. So one last example, this is example 36. We want to plant a rectangular garden along part of the 40-foot side of your house. To keep out animals, we're going to enclose the garden with a wire mesh along 3 open sides. You also cover the garden with mulch. If you have 50 feet of mesh and enough mulch to cover 100 square feet, what should the garden's dimensions be? This is a pretty complicated problem. What I suggest you do is you actually draw it out first. So we have a 40-foot side of your house. We know part of this distance is going to have a fence along it. Okay, so one side is going to be part of your house, the other 3 sides are going to be wire mesh. We have 50 feet of mesh to cover the side. So we have, let's say, call this x, because we don't know what it is, and call this x because it's a rectangle. So these 2 sides have to be the same. And we're using 50 feet of mesh, so we're going to call this 50 minus 2x, because this is going to eat up some of our 50, this is going to eat up some of our 50. So all that's left for this side is 50 that we started with minus the 2 sides that we already built. Hopefully that makes sense to you. Okay, now we also know we want to cover this garden with mulch. So we're going to pretend that our mulch is green. Okay, I know mulch is typically brown or red or whatever, but in this case for this garden it's green. And we have 100 square feet. Well, anytime you're talking about covering something, that's area. So, and we're talking about a rectangle, so the area of a rectangle is given by length times width. But check it out, we got length and width, so let's plug in what we know. So area is equal to x times 50 minus 2x. Okay, and we know that our area for this particular garden is 100, so let's plug that information in as well. Now we want to figure out what each side should be. So I need to figure out first what x is. And I just pick x as my letter. You can use whatever letter you want. I want to do this by graph. y1, y2. Alright, so let's go to y equals, clear out all our other stuff. 100, and then x, parentheses, 50 minus 2x. It's important that you, when you plug in, you use parentheses. If you don't, it's not going to come out right. Alright, so I have 2 points of intersection. So I want to say second count, option 5, first curve enter, second curve enter, yes. My first point of intersection is x equals 2.19. My second point of intersection, let's find that. Second count, option 5. First curve enter, second curve enter, yes. Find the one on the right. Move into position. Hit enter. X equals 22.8. I just want to go to y equals, double check that I typed in everything correctly, and I did. Okay, great. So those are my two x's. What I want to do is to the guardian's dimensions be. I want to figure out what value of x is going to give me the best dimensions. So think about what makes more sense. If I plug in 2.29 here, that means that this side of the fence is only 2.19 feet. It doesn't make a lot of sense. So instead, it makes more sense for this side to be 22.8 feet. That would mean this side is also 22.8 feet. And then this side, if I plug in 50 minus 2 times 22.8, so let's use our calculator. 50 minus 2 times 22.8, that's 4.4. Okay? So the guardian's dimension should be 22 by 8 by 4 by 4. Okay? That's it for this video. That's it for this chapter. Please, 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 if you got questions, let me know. I want to help you.